Students, all of you, good evening. Welcome to the session. Continuation of chapter 2, that is sinusoidal steady state analysis. With respect to chapter 2, I am starting lecture 5. Students, in the previous session that I given some basics with respect to phasor analysis, what the phasor representation, and how to solve the different models of questions with respect to phasor representation. All these are completed. Now we have to concentrate if the sinusoidal AC source is applied to R element, that is resistive, inductor and capacitor. What are the observations? Then after that, we have to see series connection of RL, RC, RLC, then parallel connection of RL, RC, RLC. First, we have to concentrate for each element separately. If the sinusoidal AC source is connected across resistive element, what are the observations? If it is connected across inductor, what are the observations? If it is connected across capacitor, what are the observations? The first one is AC sinusoidal source, that is sinusoidal AC source across resistance. That is sinusoidal AC source across resistance. Sinusoidal AC source across resistance. Students, concentrate. Take the resistive element. Across this element, we are connecting sinusoidal AC source. This is the sinusoidal AC source. This V equal to Vm sin omega t. V equal to Vm sin omega t. Let the current in this element is I, the element is R. Then first I am writing in time domain. In time domain. What is the voltage? V equal to Vm sin omega t. Then what the current? I equal to Vm sin omega t by R. This is equal to, you have to take the Vm by R is Im, you have to take. This is equal to Im sin. That is, we are getting V equal to Vm sin omega t. I equal to Im sin omega. Then what is the angle between voltage and current, students? This is equal to 0 degrees. Because V equal to Vm sin omega t, I is also Im sin omega t. What is Im here? I taken this Im equal to Vm by R. The angle between voltage and current is 0 degrees. The angle between voltage and current is 0 degrees. Then what is the observation? Therefore, for resistive element, voltage and current is in phase. Voltage and current is in phase. In phase. That is, the angle between voltage and current is 0 degrees. If you write in frequency domain, this is the observation in time domain. Same observations I am giving in frequency domain. Yes, in frequency domain. We know that in frequency domain, you have to write V bar equal to I into Z. That is I bar into Z. But even though resistor is transferred to the frequency domain, the Z is remains R only. Told already. If these elements are transferred to the frequency domain, if applied for frequency domain, then it offers the impedance. But for resistor, the impedance is R only. There is no change. That's why V bar equal to, that is I bar into R squares. V bar equal to I bar into R. Then what is R equal to? This is V bar by I. Therefore, for resistive element, the voltage and currents are in phase. The voltage and the currents are in phase. Therefore, for resistive, V and I are in phase. If V and I are in phase, then what is the angle between voltage and current? 0 degrees. The angle between voltage and current is 0 degrees. That is, if angle between voltage and current is 0 degrees, what is the power factor? Cos of angle between voltage and current, that is cos 0, that is unity power. Therefore, for resistive element, voltage and currents are in phase and it is a unity power. How to define the power factor? The fundamental definition of power factor is cos of angle between voltage and here I am writing. Therefore, power factor equal to the fundamental formula for power factor equal to that is angle between cos of angle between voltage and current. That is the fundamental formula for power factor. Angle between voltage and current. Okay, this is the power factor. But for resistive load, what is the angle between voltage and current? 0 degrees. Resistive element, na? That is unity power factor. For resistive element, the power factor is unity. This is one observation. Now we have to calculate what the instantaneous power. How to calculate instantaneous power? For resistive element, instantaneous power PI equal to voltage into current. That is instantaneous voltage into instantaneous current. What is instantaneous voltage, friends? Vm sin omega. What is instantaneous current? Im sin omega. V equal to Vm sin omega t, I equal to Im sin. Then the instantaneous power equal to that is Vm Im sin square omega. This is equal to Vm Im. How to write sin square omega t? 1 minus cos 2 omega t by 2. Therefore, what is instantaneous power? The instantaneous power equal to Vm Im by 2 multiply with Vm Im minus Vm Im by 2 into cos 2 omega. Okay, this is the instantaneous power source. That is Vm Im by 2 minus Vm Im by 2 into cos 2 omega. But what is the observation here? What is the supply frequency? The supply frequency is omega. We are giving supply is frequency, angular frequency is omega. But what is the frequency of instantaneous power, friends? 2 omega. Therefore, if supply frequency is omega, the frequency of instantaneous power is 2 omega. Similarly, if the supply frequency is f, what is the frequency of instantaneous power? It is a 2f. Frequency of instantaneous power is 2f. Right on? If supply frequency is f, if supply frequency equal to f, the frequency of instantaneous power is 2f. Power is 2f. Now you know the expression for instantaneous power. You have to find what is the average power. What is the average power? You have to find what is the average power. One method to calculate average power is this constant indicate the average. This is constant, that is the average value. Then Vm Im by 2 is the average power. You can also write like this, na? Vm by root 2 into Im by root. Then Vm by root 2 is Vrms. Im by root 2 is Irms. The instantaneous power is also equal to, sorry, the average power is also equal to product of RMS voltage into RMS current. That is Vm Im by 2. That is, I am writing Vm by root 2 into Im by root 2. Vm by root 2 is Vrms. Im by root 2 is Irms, friends. Then average power equal to, that is Vrms into Irms. Okay, this is the average. That is, in the case of resistive element, the average power is not equal to 0. There exists some average. Now, with this knowledge, if you try to draw the waveforms, friends, what is the supply voltage we are giving? Vm sin omega t. Okay, this observation is important. Yes. So this is Vm sin omega t. But the magnitude of current is less than the voltage. The magnitude of current is less than the voltage. Let this is the Im. I'm taking this is the Im. That is Im sin omega. This is V and this is I. So this is omega t axis. Now you have to calculate instantaneous power. What is instantaneous power, students? V into I. That is product of voltage and current. If you multiply these two, voltage and current, this is positive, 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 this is positive. If you multiply voltage and current, students, that is instantaneous power. Positive into positive, we can get positive. Positive into positive, we can get positive. You can get the shape like this. This is the frequency of instantaneous. Frequency of instantaneous power is 2f. But these two are multiplied. That's why you are getting the shape like this. These two are multiplied. This also multiplied. Like this. Sorry. Positive into positive is positive. Na? But what about here, friends? Product of voltage into current. Na? Negative into negative. Again, it is a positive. Correct? Negative into positive. Negative into negative is a positive. Voltage is negative, current is also negative. This negative into negative is positive. This we are getting the positive. Positive into positive is the positive. Multiply those two. We are getting like this. And negative into negative is positive. Then what about this power? This is the instantaneous power. For which element? Resistive. This is for resistive elements. So this is the instantaneous power. Then in one cycle, how many pulses? 2 cycles. That's the reason why what the frequency of instantaneous power? 2f. If supply frequency is f, then frequency of instantaneous power is 2. Because here how many pulses per cycle we are getting? How we are getting this one, sir? Product of voltage into current. Positive voltage, positive current, positive. Negative voltage, negative current, positive. This is the instantaneous power. Therefore, for resistive elements, average power is not equal to 0. For resistive element, average power is not equal to 0. For this case, if you find the average power, for this case, then the average power equal to Vm Im by 2 squares. This is equal to Vm by root 2 into Im by root 2. This is equal to Vrms into IRMS. That is the average power. See, for example, if the question is asked like this. If heater is operated with 230 volts 50 Hz, if the heater is operated with 230 volts 50 Hz, heater is operated with 230 volts 50 Hz, then the frequency of instantaneous power is dash. Then frequency of instantaneous power is less. What the frequency of instantaneous power, friends? Can anybody? What is the answer? Frequency of instantaneous power is, if frequency is omega, it is instantaneous power is 2 omega. Then frequency of instantaneous power how much? How much, friends? 2f. That is 2 into 50. That is 100 Hz. Like this, you have to analyze. That is sinusoidal AC source across R element. If there is a sinusoidal voltage source across R element, AC source across R element, this I am drawing V, I and P curve. V, I and P curve. This is drawn with respect to omega t axis. Next. Sinusoidal AC source across inductor switch. The second one is, how to write? sinusoidal AC source across inlet. Then how to analyze? Come on. Sinusoidal AC source across inlet. I think you got this one. This power. This is the instantaneous power. How you got this one? Product of voltage into current. Positive voltage, positive current, positive. Negative voltage, negative current. Negative into negative, positive. That's why it's instantaneous power. That point you have to do. Then sinusoidal AC source across inductor. Can you try this? Analyze. Come on, students. Sinusoidal AC source across inductor. Let's consider any one inductor element. This is inductor element. This is AC source is connected. This is L. Let the current is I. And then this is V of. The supply voltage is V of. First, I'm writing in time domain, students. Time domain. In time domain letter, I'm taking I equal to Im sin omega. Take the I equal to Im sin. Once you know the current in a inductor case, how to calculate voltage? V equal to L into d by L into d by dt of what is I? Im sin omega. You have to write like this: V equal to, you differentiate with respect to t, Im omega L cos omega. Im omega L cos omega. Shall I write like this one, friends? V equal to Im omega L sin. I'm writing this is sin 90 plus theta is cos theta. Sin of omega t plus. Yeah, this is V. Im omega L sin omega t plus 9. This is I equal to Im sin. Then what the observation? This is plus 90 now. In pure inductor, voltage leads the current by angle of 90. Voltage leads current. Voltage leads current by angle of 90. Correct? This is plus 90 now. Then opposite also you can tell. Voltage leads current means current lacks voltage. Current lacks voltage. How was, friends? Current lacks voltage by angle of 90. Current lacks the voltage by angle of 90. This is in time domain. You have to write in frequency domain. We know that if it is transferred to the frequency domain, these elements are acts as a impedance. These elements are acts as a impedance. Next, write down in frequency domain, students. In frequency domain, how you can write? These elements are acts as a, in frequency domain, these elements are acts as a impedance. Then if you write the in frequency domain, V bar equal to I bar into Z. Then V bar equal to I bar into, we know that what is the impedance of the inductor? What is the impedance of the inductor, friends? The impedance of the inductor is J into omega. J omega. This is J into omega. Correct? You have to write the impedance of the inductor equal to J into omega. Then from this, V bar, this is, you can write like this now. I into omega L at angle of 90 degrees. At angle of 90. Then V bar equal to I into XL at angle of 90 degrees. Then what is the Z equal to? V bar by I bar. This V bar by I bar. That is, what is the observation here? Angle is plus 90 degrees now. Angle is plus 90 degrees. That is, voltage leads current. Plus 90, voltage leads current by angle of 90 degrees. Voltage leading means current lagging. Current lacks voltage. Current lacks voltage. How much, friends? By angle of 90 degrees. Current lacks voltage by angle of 90 degrees. This is V bar equal to I into XL angle of 90 degrees. That is, if you take like this is a vector representation. This one. This is V bar and this is I bar. How to write like this? Current lags the voltage. Lagging means clockwise direction. How many degrees? 90 degrees. This is clockwise. Current lags. Clockwise you have to measure as a lag. Counterclockwise you are measuring as a leading. Then voltage leads current by angle of 90 degrees. Voltage leads current by angle of 90 degrees. Or you can also represent like this. This is V bar and this is I bar. If you measure in clockwise direction, current lags the voltage. Clockwise lagging. Counterclockwise leading. Voltage leads the current. Understand, sir? Current lags the voltage. Clockwise we are measuring now. Clockwise lagging. Clockwise is lagging. Counterclockwise we are measuring as a leading. Then how we can define? Clockwise na current lags the voltage by angle of 90 degrees. Voltage leads the current. Current lags the voltage or voltage leads the current. Angle of. Okay, this about for pure inductor, voltage and current. That is, what is Z equal to? V bar by I. You write modulus of V at angle of 90 degrees. At angle of, this is equal to modulus of V at angle of 90 degrees. At angle of 90 degrees. V by I. Then what is V by equal to? At angle of 90 degrees is J. At angle of 90 degrees is J. V by is Z. So V by I is XL. What is V by I? That is the XL. This you have to write V by I is XL. XL at angle of 90 degrees. That is JXL. This is positive or negative? Positive. That is for inductive, for inductance, the reactance is positive. For inductance, this is taken as a positive. Next. What is instantaneous power in this case, friends? Instantaneous power. What is the instantaneous power? How to calculate instantaneous power, sir? Come on, do it. The instantaneous power equal to V into I. Then instantaneous power equal to, what is V? This you have to take. The instantaneous power equal to V into I. The instantaneous power equal to V into I. Shall I write like this? This is equal to, this is V na? Im into omega L na? This Im into XL. Im into XL. This is equal to Vm cos omega. Vm cos. That is I equal to Im sin omega t, V equal to Vm cos omega. This Vm cos omega t into Im sin omega. Then what is instantaneous power? This Vm Im sin omega t cos omega. Multiply and divide with 2. That is Vm Im by 2 into 2 sin omega t cos omega. Then what is instantaneous power, friends? Vm Im by 2 into sin 2 omega. This is the instantaneous power. Vm Im by 2 into sin 2 omega t. Can you calculate what is average power? Average power. This P average is equal to 1 by 2 pi integral 0 to 2 pi pi d omega t. You substitute instantaneous power, you find the average value of this, we can get 0. Very good. But in the resistive load, purely resistive load, the average power is not equal to 0 because there is a constant term is there. This is the average. This is the constant term now. This is average power. But what is the average of this part? The average of this part is 0 because average of cos is 0. The average of this part equal to 0. That's why the total average power equal to Vm Im by. But here there is no any constant term now. That's why the total average power equal to 0 here. In the case of pure inductor, average power equal to 0. What is the frequency of instantaneous power? Frequency of instantaneous power. The frequency of instantaneous power is also 2f. Because actually I taken supply is which one? Sin omega t. Current or supply. But here we are getting 2 omega. That's why frequency of instantaneous power equal to 2. Now if you draw the instantaneous power curve, that is the frequency of instantaneous power equal to 2. For resistor, frequency of instantaneous power is 2f. For inductor also it is a 2f. That is, if supply frequency is f, If supply frequency is F, then frequency of instantaneous power equal to 2F. That is frequency of instantaneous power equal to F. Instantaneous power equal to 2F. That is the mean. Because of 2. Now, if you draw the curve, power curve here for pure inductor, listen. F I equal to Im sin omega t. What is I you taken? I equal to Im sin omega t. That is I is sine wave. I is sine wave. This is for one cycle. In one cycle, I equal to Im sin. Okay. And V, I, Pi curve I am drawing. Then what about this is pi, this is 2 pi, this is omega. This curve is which curve? I curve. Then what is V, friends? V equal to, what is the V? Sin omega t plus 90. That is voltage is leading current. Voltage is leading current by angle of 90 degrees. Now take like this. Voltage is leading the current. Then this is the voltage wave. This is by angle of 90 degrees it is. Voltage leading the current by angle of 90 degrees. Voltage is leading the current by angle of 90 degrees. Clear? Okay. This is by angle of 90 degrees. This is which curve? Voltage curve. This is voltage curve. This is leading by angle of how much? 90 degrees. Now, how to get instantaneous power, friends? Instantaneous power equal to V into I. Product of voltage into current. You have to draw the product of voltage into current. Draw the product of voltage into current. This one. This is V. This is voltage curve. This is voltage curve. And this is current curve. Voltage into current. Current is 0, 0. Positive, positive, positive. Here you are getting maximum value. After this, it is decreasing. Just I am multiplying voltage into current. If you multiply voltage into current, here voltage 0, that's why power also 0. Voltage 0, that's why power is also 0. Just you have to multiply the voltage into current. Multiply the voltage into current. This one. Next. Positive, negative. Current is positive, voltage is negative. Then you can get negative. Then you can get negative. Then at this point, it is 0. Why power is 0? Because current is 0. Power is 0 because current is 0. Because current is 0. Next, again. Negative. Current is negative, voltage also negative. Negative into negative, positive. Negative into negative, positive. Again, it is a 0 here. Negative into negative, positive. Then you have to multiply. Then you can get 0 here. Why it is 0? Because voltage 0. Voltage 0, power is 0. If any one is 0, power becomes 0. Again, this is positive. This is negative. Negative into positive. Negative. Again, it is 0. Like this here. That means for one cycle of supply, friends, for one cycle of supply, see this one. For one cycle of supply, how many cycles of power we are getting? This is one cycle of supply, na? This is one cycle of supply. How many cycles of power we are getting? Here we are getting 2 cycles of power. That's why, what is the frequency of instantaneous power? The frequency of instantaneous power equal to 2F. This is the formula. The frequency of instantaneous power equal to 2F. Now, if you see what is the average power? Average power in one cycle. If you take the area under the curve, what is the average power in one cycle, friends? This is, if you take the average power, positive area, negative area is equal. Then positive area, negative area is equal. Positive area, negative area is equal. Then what is the average power? 0. This is the proof. Clear? This simple, sir. How I am drawing the power curve? Just I am multiplying the voltage into current. Just I am multiplying the voltage into current. Here also, for resistance also, I multiplied voltage into current. Positive, positive, positive. Negative, negative, positive. Here, we are not getting any negative off cycle of power. That's why average power is not 0 here. But here average power is 0. Because positive, negative, positive, negative. This is which curve? Power curve. This is the instantaneous power curve. Clear, friends? That you have to concentrate. Therefore, average power is 0 means what is the meaning of this? Average power is 0 means it indicates pure inductor cannot takes any power, cannot consumes any power. That is the meaning. Therefore, pure inductor cannot consume any power. Consume any power. Any power. There is any active power. There is no any active power consumption. So that you have to consider. In this case, what is the angle between voltage and current? The angle between voltage and current is 90 degrees. Current lacks voltage or voltage leads current. Current lacks voltage or voltage leads current. Clockwise angle lagging. Anti-clockwise angle leading angle. You have to measure as a leading. This is for voltage across a sinusoidal AC source across inductor. Next, you have to see a sinusoidal AC source across capacitor source. The third one is sinusoidal AC source across capacitor. Sinusoidal AC source across capacitor. Across capacitor. Yes, let's consider this is the capacitor element. Across this, we are connecting a sinusoidal AC source. The sinusoidal AC source. This is capacitor. That the voltage equal to V equal to Vm sin omega t. Then this is the current I. Then in time domain, V equal to Vm sin omega t. Voltage is Vm sin omega t. What is I equal to C into dV by dt? C into d by dt of what is V? Vm sin omega. Then what is I equal to? That is C Vm omega cos omega. Just differentiation steps. Cos omega. This is equal to Vm omega c into cos omega t. Shall I write like this? Vm by xc into cos omega. We know this, xc equal to 1 by omega c. Then omega c equal to 1 by xc. That is this formula is capacity. Then what is I equal to? Im cos omega. I equal to Im cos omega. This Im cos omega t you also write Im sin omega t plus 90. Sin 90 plus omega t cos omega. This is voltage and this is the current. What is Im I written here? Vm by xc. That is what is the observation here, students? Plus 90 degrees now. Current leads the voltage. In time domain, directly I'm telling, current leads the voltage by angle of 90 degrees. Angle of 90 degrees. Current leads the voltage by angle of 90 degrees. Or current leads means voltage lags. Voltage lags the current. Voltage lags the current by angle of 90 degrees. That is, you have to write in frequency domain. In frequency domain, you write in frequency. If you write in frequency domain, V bar equal to I bar into Z. What is the Z? Capacitive impedance. I will explain. Minus J by omega C. That is I bar into minus J XC. I bar into minus J XC. Shall I write like this? I into XC at angle of minus 9. I into XC at angle of minus 9. That is V bar equal to I into XC at angle of minus 90. Then what the observation? Voltage lags. Minus 90 na? Voltage. Minus 90 degrees means lagging. V bar lags I bar. I bar. Then by angle of 90 degrees. By angle of 90 degrees. Or I bar leads V bar. By angle of 90 degrees. Correct? By angle of 90. This minus 90. 34. Yes. Then if you represent in phasor, you represent like this. Which is leading? Current is leading. Current leads the voltage by angle of 90 degrees. This is counterclockwise. Voltage lags clockwise. Clockwise angle is lagging. Counterclockwise angle is current leads the voltage by angle of 90 degrees. We can also represent like this. This is also correct. This is I, this is V. How many degrees, friends? 90 degrees. If you measure in counterclockwise direction, leading. If you measure in clockwise direction, lagging. Lagging measuring angle is negative. Leading measuring angle is positive because counterclockwise direction, leading. We are measuring like this now, leading. Current leads voltage. We are measuring like this now, voltage lags current. Okay, that point is very important. Now, what is the instantaneous power? Can you calculate what is instantaneous power here? Instantaneous power. Then for purely capacitive element, what is instantaneous power? The instantaneous power is one point you have to remember, friends. Here I given the angle between voltage and current is 90 degrees now. 90 degrees. Then what is the power factor? Cos 90. ZPF. Zero power factor. Pure inductor power factor is ZPF. But here current is lagging. With respect to current, you tell. Current is lagging. That is lagging. ZPF lagging. Current is lagging here. Current is lagging. This is I lags V. Reference is you take the current. I lags V. Then for pure inductor, what is the power factor? For pure inductor, power factor is ZPF lag. Zero power factor lagging. At that point, then voltage lags the current here. Current leads. Then what is instantaneous power, sir? V into I. What is V? Vm sin omega. What is I you got? I am cos omega. I am cos omega. Then what is instantaneous power? Instantaneous power equal to Vm Im multiply and divide with 2. 2 sin omega t cos omega t. Multiply and divide with. What is 2 sin omega t cos omega t? Sin 2 omega. That is Vm Im by 2 into sin 2 omega. Then what is the frequency of instantaneous power? 2f. Here also 2f. 2 omega na. Actually supply I taken sin omega. Omega. Supply is omega. But what is the frequency of instantaneous power? 2 omega. Therefore, frequency of instantaneous power. It may be resistive element or inductive element or capacitive element. Then frequency of instantaneous power equal to 2f. Instantaneous frequency. Frequency of instantaneous power equal to 2f. Clear? This is Vm Im by 2 sin 2. Can you calculate what is the average power? If you find average of this, it becomes 0. Because there is no constant term. Sine function. Sine average is 0. What is the frequency of it? But it is a 2 cycles, no doubt at all. But if you find the average power, that is P average equal to 1 by 2 pi integral 0 to 2 pi pi d omega. You substitute and integrate, substitute the limits, we can get 0. What is the meaning of average power is 0? Capacitor cannot consume any power in one cycle. Capacitor, pure capacitor. I'm talking about pure capacitor. Cannot consume any power. Whatever the power is, whatever the energy stored, same energy is released. That's why cannot consume any power. Or cannot consume the power. That is active power, it cannot consume. Average power is the active power. Cannot consume the power. Then what is the power factor? The power factor equal to, that's the angle between voltage and current, 90 degrees. But here current is lagging or leading? Leading. I leads V, I told already. Then power factor equal to, the angle between voltage and current is 90 degrees. The current is leading. Then what is the power factor? Then power factor equal to cos of angle between voltage and current, cos 90, 0, ZPF, 0 power factor. But current is leading, that's why it is taken as a leading power factor. The power factor is decided angle between voltage and current and is lagging. Lagging and leading indicates the nature of the load. Lagging and leading indicates the nature of the load. Here, nature of the element. Capacitor, na, that's why leading. Inductor, that's why it is lagging. Then if you draw the curve, just like whatever I explained for L element, here also I'm drawing for C element, the curve. I'm drawing here voltage, current, and instantaneous power. Voltage, current, and instantaneous power. That is what is the observation here. If you draw the curve, V equal to Vm sin omega. This is the voltage curve. This is for one side. Correct? V equal to Vm sin omega t. Second drawing. This is V equal to Vm sin. Then what about this is voltage. But current is leading. Current is leading. Current leads the voltage by angle of 90. This is the current curve. Current leads the voltage angle of 90. This is for 1 second. Current leads the voltage. Voltage by angle of 90 degrees. Okay. Current leads the voltage. Now you have to draw the power curve. Power is nothing but a product of voltage into current. Product of voltage into current. Here, this is current. Here, voltage 0. Even though current is exist, power is 0. Then you get the curve like this. Just product of voltage into current, sir. You multiply that, you can get this curve. This is the instantaneous power. This is PI. That is for one cycle of supply. How many cycles of one cycle of supply? This is one cycle of supply. How many cycles of power we are getting? 2 cycles. That's why frequency is 2f. Then if you see the average, if you calculate the average, positive area equal to negative area. Positive area equal to negative area. Then what the average power? The average power equal to 0. Average power. Yeah, this about if sinusoidal AC source is applied across resistive element, inductor, and capacitor, what are the observations? The sinusoidal AC source is applied. Then here I am giving note points that you have to concentrate. For resistive element, voltage and currents are in phase. Voltage and current in phase. In phase. That is voltage and currents are in phase. Then what is the angle between voltage and current? 0. Then what is the power factor? Cos 0. That is unity power factor. For pure inductor element, current lacks the voltage. Current lacks. Exactly opposite. If current lacks means voltage leads. Just one statement only I'm giving. Current lacks the voltage. Current lacks the voltage. By angle of 90 degrees. Current lacks the voltage by angle of 90 degrees. That is, current lacks the voltage by angle of 90 degrees. Then you have to write the angle between voltage and current is 90 degrees. The angle between voltage and current is 90 degrees. But this is lagging. Then what is the power factor? Cos 90. That is ZP of lag. For pure capacitive element, current leads the voltage. Current leads the voltage by angle of 90 degrees. How it is, I will explain. That is, angle between voltage and current is 90 degrees. It is a leading. That's why power factor is taken as a lead. Then what is the power factor? Cos 90. That is ZP of lead. ZP of lead. For this case, what is the average power? 0. For this case, what is the average power? 0. But resistor consume the power. That's the reason why average power equal to Vm Im by 2. It's also equal to Vrms into Im. Vrms into Irms. With this knowledge, now you have to see combination of elements. Combination of elements. Individually, I explain. You have to see the combination of it. That is AC sinusoidal source across series circuits. The next concept is AC sinusoidal source across series circuits. Across series circuits. What are the observations? Very, very important concept that you have. The first one is that is a series RL circuit. Series RL circuit. Let's consider a series RL circuit. This is resistance. This is inductance. This R and L is connected in series. Across this, a sinusoidal V. That is a sinusoidal voltage is V. That you have to take V equal to Vm sin omega t. Vm sin omega t. Then capital V equal to RMS value of supply. RMS value of supply. This is taken as a VM by. Let the voltage across the resistor is VR and voltage across the inductor is VS. This voltage I am taking as a VR. Take this is the VR. Okay. And the voltage across the inductor is taken as a VR. This is where VR and VL is both are RMS values. VR is RMS value and VL is also RMS values. Don't confuse. These are taken as a RMS values. Now, in phasor representation, you know this V bar equal to VR plus VL. Both are RMS values, that is VR plus. Then V bar equal to, how to write VR? I into R. How to write VL? I into JXL. The impedance of the inductor is JXL. That is JXL. The impedance of the inductor is JXL. Correct? This is JXL. Then V bar equal to, take I is common, R plus JXL. R plus JXL. Then R plus JXL. Therefore, this is for series RL. For series RL, impedance Z equal to R plus JXL. Very important. For series RL combination, impedance Z equal to R plus JXL. Then you have to write, what is VR here? VR equal to IR at angle of 0 degrees. What is VL, friends? VL equal to I into JXL. No? This is equal to I into XL at angle of 90 degrees. Then shall I write like this? V bar equal to I bar into Z, where Z is impedance of, for series RL circuit, what is the impedance? R plus JXL. For series RL, impedance Z equal to R plus JXL. VR equal to IR. This VL equal to I into JXL, that is I into XL at angle of 90 degrees. Now you have to draw the different phasor diagrams. Yes. The phasor diagrams, if you draw these phasor diagrams here, this is important. Here I am drawing phasor diagram. Let it is a series circuit. In a series, current is constant. I am taking the reference is current. What the angle between voltage across the resistor and current? 0 degrees. That's why VR is in phase with current. VR is in phase with current because it is a 0. But what about VL? VL leads I. VL leads I by angle of 90 because plus 90 degrees now. Plus 90 means leading. VL leads I means this is I. VL leads I. This is VL. This is VL. This, if you measure in counterclockwise direction, then VL leads I by angle of how much? 90 degrees. Clear, sir? This is in phase because of 0 degrees. Plus 90 degrees now. VL leads I by angle of 90 degrees. Then this VR plus VL, this VR plus VL equal to V. VR plus VL equal to V. This is the V. VR plus VL equal to. Let this angle is theta. Now what is V? Where V equal to, one observation, V equal to square root VR square plus VL square. According to parallelogram law, VR square plus VL square plus 2 VR VL cos of angle between VR and VL. What is the angle between VR? This is 90 degrees means what is this angle also? 90 degrees. Angle between VR and VL is actually according to parallelogram law, sir, like this. VR square plus VL square plus 2 VR VL cos of angle between voltage VR and VL 90. Cos 90 0. This becomes 0. Then we can get VR square plus VL square. That's why this is V equal to square root VR square plus VL square. Clear? That you have to concentrate. Very important observations. Then you write what is cos theta from this one? Cos theta. Define cos theta. VR by V. VR by V. Cos theta is VR by V. This is also equal to VR is I into R. What is V equal to? This one. I into Z. I cancel. R by Z. This is also called power factor. Cos theta equal to VR by V. That is R by Z. This is the power factor. From this, you define what is sine theta. Calculate sine theta. Sine function, VL by V. What is tan theta? Any formula you have to write. Tan theta, VL by VR. Tan theta equal to VL by. Different formulas that you have. What the angle between V and I? The angle between V and I is theta. What the angle between VR and VL, friends? What the in this case, what the angle between VR and VL? Come on, 90 degrees. Angle between VR and VL is 90 degrees. The angle between VR and I, so angle between V and I is theta. Angle between V and I is theta. Clear? This phasor diagram with respect to. I am drawing impedance triangle. Impedance triangle. For same series RL circuit, I am drawing impedance triangle. If you draw the impedance triangle, what is impedance? Z equal to R plus JXL. R plus JXL. Then this is resistance. JXL 90 degrees. This is XL. And this is Z. This angle is theta. Now from this, what are the observations? What is the Z you have to write? Magnitude of Z. Square root R square plus XL square. Every formula is in. From this, what is the cos theta you have to write? R by Z. That is power factor. What is the sin theta you have to write? Sin theta. XL by Z. What is the tan theta you have to write? XL by R. Very important, omega L by R. In RL circuit, series RL circuit, tan theta equal to. And from this, we calculate theta. Tan inverse XL by R. Tan in. Wherever the RL circuit is there, how to calculate the angle? Tan inverse XL by R. Tan inverse XL by R. Clear? From this, what is the R equal to? This one. You calculate R equal to R by modulus of Z. This one. R equal to modulus of Z cos theta. Starting, I given this formula. What is XL equal to? This you take modulus. Modulus of Z sin theta. What is XL? Inductive reactance. This is equal to omega. Okay, this is impedance. You can also draw the power triangle. You can also draw the power triangle. How to get the power triangle? You tell me. Power triangle. Simple. In impedance triangle, every vector is multiplied with I square. This is impedance triangle. This is impedance triangle. Multiply with I square R, I square XL, I square Z. This is theta. What is I square R active power? What is I square XL reactive power? Inductive, reactive. What is I square Z apparent power? Every vector is multiplied with I square, then you can get the power. Clear? Then what is S equal to here? S equal. From this also you can write any form in terms of powers also. What is the power factor? Cos theta. What is the cos theta? P by S. That is active power by apparent power. Important form. Active power by apparent power is called power factor. Apparent power. Then what is the tan theta? Tan theta equal to that is QL by P. Tan theta equal to QL by P. Then what is the apparent power, friends? The apparent power equal to apparent power. All these observations important to solve any question. S equal to I square into Z. Shall I write like this? I into Z. I into Z into I. What is I into Z? V. V into I. What is I into Z? V na. It's V into I. That is product of voltage into current. This is called apparent power. Then what are the units? What are the units? Volt amp. Volt amps. That is apparent power. Product of voltage into. Next. What is the inductive reactive power? What is the inductive reactive power? Inductive reactive power. The inductive reactive power equal to QL equal to I square into XL. Shall I write like this? This I square into XL I am writing as a I into IXL. I into IXL. Shall I write like this? This is I into IXL. I into XL is modulus of Z sin theta. This I into Z is V. I V sin theta. Therefore, what is the inductive reactive power VI sin? Just like VI sin pi, that is VI sin theta. Is that? What are the units? This is equal to I square XL. I am derived from I square XL only, na? VI sin theta, that is equal to I square. Both are same. What are the units? Where? That is reactive volt amperes. The units of reactive power is reactive volt amperes. Reactive volt amperes. Reactive volt amperes. What active power? What are the active powers? Active power P equal to I square R. Shall I write like this? That is I square into, what is R? Modulus of Z cos theta. This is I into IZ into cos theta. What is IZ? V. IV cos theta. Then what is active power equal to? I square R. This is equal to VI. Both are same. I square R, VI cos theta, both are same. This is VI cos theta. What are the units of active power? Units watt. The units of active power is watt. Yes, friends. Here, one more power equation that I have to explain here, that you have to see. You know that Z equal to R plus JXL. R plus JXL. I into Z. This, you have to write I square. I square into Z. R plus J into I square XL. Multiply both sides by I square. What is I square Z? I square Z is which power? This I square Z, no? This I square Z is which power? Apparent. That I given apparent. This is yes. I square R is P. J into Q L. P plus JQL. P plus JQL. This power is called complex power. In this case, it is called complex power. This is also called, that is apparent power is also taken as a complex power if you represent like this. Then if there is a real and imaginary part is represented, that is called X power. These are the different power calculations. That is what, with respect to series RL circuit, what are the points you have to remember? How to write the impedance, this is important formula. How to write the resultant voltage V. And from this, what is cos theta? What is the cos theta power factor? Then what is the impedance triangle? Once you know the impedance triangle, easy to write power triangle. Every vector in the impedance triangle is multiplied with I square. Then you can get the power. I square Z equal to VI. I square XL equal to VI sin theta. This is the proof. I square R equal to VI cos theta. This is the proof. This apparent power, if you write real and imaginary parts, then it is taken as a complex power. Then it is taken as a complex power. So these are the points you have to remember with respect to series RL circuit. With respect to series RL circuit, these are the observations. Next, I have to discuss series RC circuit and series RLC circuit. After that, you go for the parallel RL, parallel RC, parallel RLC. That is about the today's session. Next session, we'll continue with RC circuits. Students, any doubt? Please go through this, whatever the concept I explained once again, and I will share this PPT in my Telegram channel. Please take this one. Please practice one time, whatever the concept I explained. During solving of the problems, all these observations are important. Thank you. I'm ending the session.